Why are we here today? We are here today to talk about consensus algorithms and or mechanisms. So I hope that's why you think you're here. So basically, the consensus mechanism is a fairly critical section of every blockchain. So it's fairly important that we understand, what they are, what they do, why we want them, and why I'd pick one over another. We're then going to go through a few examples of what consensus mechanisms are currently available for use in Ethereum. And we'll be comparing and contrasting some good and bad bits about all of them. After that, we're going to do a deep dive into IBFT 2. So really, IBFT 2 is the new consensus mechanism that has just been released in Pantheon. We're going to talk about where it comes from, what it does, how it does it, and just take you through the code.
Guys named Rudy on this call, and they're all German.
They're going to have trouble. So anyway, after that, we will be running up a quick demo where we'll show you how to spin up an IBFT 2 network, show how it behaves, explain some of the inner workings of why we've set it up and how we've set it up. We'll then do things like adding and removing validators from the authorized pool of miners. And then we'll transfer some funds and just kind of try to prove that Ethereum works the same way it always has, just with a replaced version of proof of work. Now on there it says that I'm going to deploy a contract, but the truth is I'm just not going to do it. I'm really sorry if that's going to make your day, but it's not going to happen. Anyway, so before we go any further, I'd love to make a few friendly reminders. Can you all please mute your microphones if you haven't already? I would love to hear what you have to say, but maybe at the end. Ask as many questions as you like in the chat. We will pause to handle them. There's like a full-on Q&A session after the demo, which is at the end of the presentation. And we really do want to dive into questions and help people out and see where we can get to. As you probably worked out, this is being recorded, so don't do anything you may regret later. And once we've finished all this presentation, we will be packaging up the recording, the materials we use, and we'll email it out to all the people who are interested. Otherwise, we'll be posting links to the chat if there's something that may help you get through what we're doing now. So let's start talking about consensus mechanisms and start talking about Pantheon. So for those of you who've been to one of our webinars before, you've probably seen a picture something like this. And this really is the Pantheon software architecture. So going from left to right on this picture, you can see we have our core code. That's really the engine room of our blockchain. So that's really where we're synchronizing against our other peers, making sure that we're propagating blocks as we need to, tracking and storing transactions, and then doing a bit of mining. After that, we've got the chain processing, and that's really about when we receive blocks and when we receive transactions, how do we validate them? How do we process them? How do we make sure that this newly received block gets into the blockchain? The next section is P2P, peer-to-peer, and that's really the network, the network aspects of Pantheon. So how do we find our peers? How do we bind to our peers? How do we share messages with them? How do we recognize the chain state and the reputation of any given peer? And then apparently we have a whole lot of schedulers, which I do not have the knowledge to speak on. And finally, we've got the state. And the state of an Ethereum node really is the blockchain itself. It's the world state, which is generated from that blockchain. And there's typically a few bits of data which we have to persist in there as well, which represent the state of the consensus mechanism at any time. Now, one of the things that makes me really sad about this picture is that there's no consensus mechanism written on it. And as a consensus mechanism engineer, that's kind of bad. So maybe if we drill in, we might be able to find something slightly more useful. Oh, look at that. We found something more useful. So really what we're saying is that that miner section of Pantheon, that is our consensus mechanism. And so for an IBFT 2 miner, and this might be a little bit small, I'll get up close to read, you can see that we have these concepts in the miner of things like the literal miner. We have some proposer selection. We have message handling and gossiping. There's some peer tracking and vote management. And finally, we have some header validation rules. So I think that's a pretty good description of the main building blocks of an IBFT 2 miner. I won't go into them in details now, but we will definitely touch on them much later in this presentation. So sit pretty for a minute. Rightio. So I suppose the question now becomes, why do we need consensus mechanisms? But to me, in some respects, the question really is, why do we need blocks? And that's a weird question maybe to most of you, but really those blocks are critical such that in a distributed world, everyone has a really clear understanding of what the true world state is at any given moment. And the consensus mechanism is really the manner in which we create that block. So if you really want to step through a consensus mechanism at its highest level of abstraction, the things that it needs to do is that it needs to choose transactions from the transaction pool. It clumps them all together into a block and then attaches what I call a legitimacy seal. And it uses this sealed block to update its local world state. It then forwards that sealed block onto its peers, and each of its peers are responsible for validating the block and validating that seal, and then using the data within it to update their local world state. And at that stage, 2 of our nodes are in sync. So what is it that I mean when I talk about a legitimacy seal? Well, for proof of work, it's the nonce. It's the answer to that massive amount of calculation that proves that this block is, validly created by the miner. For Click, it's a bit more simple. It's simply the signature of one of the authorized nodes. For IBFT, it's more a group of signatures of all of that authorized nodes which endorse this block. So I know when I think about consensus mechanisms, the real crux of it is that it's a twofold problem. One, on the miner side, he has to create a seal that can be verified by a validator, and the validator needs to be able to validate that seal. So whenever you see a consensus mechanism, it literally will be a seal creator side of the world and then a seal validator. And certainly you can really see that in the way that consensus that has been created. Now, it is worth quickly saying that there is lots more validation rules that need to be conducted than just the legitimacy seal. We need to validate the time. We need to validate the ancestry of the blocks. We need to validate the mix hash, the difficulty, the gas price, the gas limit. There's probably 15 odd rules that you need to run on a block to determine its validity, but they're not necessarily interesting in the consensus mechanism world, so we'll probably leave them for now. So